Hello everyone, welcome to Bhuvigyan modules, and today in this lecture we are going to discuss the Cenozoic stratigraphy of India. So this is one of the important lectures for GSI means because you have seen in the previous trend a lot of question has been asked from the Cenozoic part of the India. So this Cenozoic part includes Paleogene and Neogene. Okay, in Paleogene we have Paleocene, Eocene and Oligocene. In Neogene we have Miocene and Pliocene. So you can remember it like P, E, O and MP. So this will come under our Paleogene and this is a part of Neogene. So if we talk about the position of India during this time, so you can see during the Paleocene and early Eocene time, means it is talking about this time period. So in this time period the position of India is like this, and here is Asia and there was a Tethys Sea present in between them. Okay, so there is a lot of marine sedimentation occurred during this time, which is also known as Subatu group. So there is a lot of marine sedimentation which took place during the Paleocene and early Eocene time, which refers to our Subatu group. Now during the Oligo and Miocene we see the continental collision occurred and we see a Murray group in this time. Okay, so Murray group is deposited during this time. So from Precambrian to Mesozoic, Himalayan region mainly witnessed marine sedimentation. So this is important. So from Precambrian to Mesozoic time, the Himalayan sedimentation is basically mostly marine. Now freshwater sedimentation is largely seen during the Cenozoic time. So freshwater sedimentation is largely during the Cenozoic time. So in Cenozoic time, two major things occurred. One was our Himalayan orogeny and Indian Asian collision, which Indian Asian collision itself resulted in Himalayan orogeny. Now, if we see the Paleogene sequence of the sub-Himalayas, it is divided into two groups, Subatu and Dharamshala. Okay. Now, outer or sub-Himalaya in the main zone of Cenozoic sedimentation. So, its distribution in Jammu and Kashmir, Punjab, Himachal Pradesh, and Uttarakhand. So, in Paleogene, we have Subatu group, Muri group, and Dharamshala group. Now, in Neogene, we have Shivaliks. Okay. So this marked the transition from marine sedimentation on the northward leading edge of the northward moving Indian plate to continental deposition. So it marks the transition. Okay. Now if you see the stratigraphy, so we have Subatu group here, which is divided into further two parts, Kakara formation and Subatu formation. So this is youngest marine sedimentary deposit. Okay. Now, if we talk about Subatu group, it is mostly dark green and red shells. Basically, it's a dark shell. It is a dark shell, and it is important for its nummulitic limestone. It is important for its nummulitic limestone, and it also has the bands of sandstone also. Okay. Now, above Subatu group, we have Dharamshala group, which is also known as Muri group. Okay, which is divided into two parts, which is Dakshahi formation, which is lower Murray, and Kasoli formation, which is upper Murray. Now, if we talk about this, so we see red, maroon, and purple sandstone, mudstone, shale, and conglomerate at the base. Now, if we move from here to here, we are basically going from marine to continental. Okay, so this is very important to understand. And above this, we have Neogene Shivaliks. Okay, so above this we have Neogene Shivaliks, and in the below we have Precambrian and Cambrian slate and limestone. Now if we discuss about the Subatu group in detail, so it is named after Subatu town, okay, which is in Solan district of Himachal Pradesh. It is thick succession of conformable strata of dark green shale and red shale. So this is very important. It is dark green shale and red shells. Okay, now interbedded with nummulitic limestone. So this is again we have already seen, it is interbedded with nummulitic limestone. Carbonaceous shale and band of sandstone is also present. Now if we talk about the location, it is present in Jammu and Kashmir, Punjab, Himachal Pradesh and Uttarakhand. Now Subatu overlies PCC slates and limestone. Okay, So this is again important. Subatu overlies PCC slates and limestone. Now, what are the fossils present here? We have nummulites here, ostracod, mollusks, fish remains are present in this. Now, Subatu group is divided into two formation, Karkara formation and Subatu formation. If we talk about age, its age is upper Paleocene to Eocene. So its age is upper Paleocene to Eocene. This is the age of it. Okay. Now it is basically a marine sedimentation, and Subatu is overlain by Muri and Dharamshala group. Now if we talk about the Muri group, which has two formations in it, that is Dakshahi and Kasoli. Okay. Dakshahi formation and Kasoli formation. Now Muri group occur in Jammu and Kashmir, and it is evaluated with Dharamshala group in Himachal Pradesh. Now it is named after Muri township in Pakistan. Now if we talk about the lithology of this, so it is red maroon, purple sandstone, mudstone and shale conglomerate is present at the base. Okay, it is freshwater deposition. This is important. This is freshwater deposition, and the age is Eocene to Miocene. The Muri group is divided into two formations. The lower Muri is known as Dakshahi formation, and the upper Muri is known as Kasoli formation. Okay. Now, if we talk about the Dakshahi formation, it is alternating red, grey, and purple clay and green, grey sandstone. Depositional environment is shallow marine to terrestrial. Okay, depositional environment is shallow marine to terrestrial. So, if we talk about here, actually we are from Subatu formation, we are moving toward the terrestrial. Okay, so Dakshahi formation is a transition between the shallow marine and terrestrial. Now, if we talk about Kasoli formation, it is gradationally overlie the Dakshahi formation. It is brown, yellow, grayish, medium to coarse sandstone. Subordinate yellow, green, and purple shales are also present. Moist to typical tropical, dry tropical environment of deposition, and upper Murray of Jammu and Kashmir, we see the Kasoli formation. So Kasoli formation is basically terrestrial. Okay. Now, if we go to the new gene of Himalayas, so the new gene of Himalayas is divided into two parts, sub-Himalayas and lesser Himalayas. So sub-Himalayas include Shivalik formation and lesser Himalayas include Karewa formation. Okay. Now, if we talk about the Shivalik group, which is in sub-Himalayas, so it is laterally extensive, exposed throughout linear belt along the Himalayas foothills between the Indus in the west and Brahmaputra gorges in the east. So this is the location of the Shivalik group. Okay. So it is from Indus in the west. It is from Indus in the west and Brahmaputra gorge in the east. Okay. Now this is the position. So here we have high Himalayan frontal thrust. This is main boundary thrust. This is main central thrust, and this is South Tibetan detachment zone. Okay. So this is the location of our Shivalik, and this is the location of our Shivalik group, and this is the location of our Karewa. Now small breaks near Sikkim we see in this formation. Okay, where your lesser Himalayas come in direct contact with the Indo-Gangetic plain. Now it includes clastic sediment deposit in Neogene Himalayas foreland basin. So this, here Indo-Gangetic deposits are there, and here the future HFT, which is a Himalayan frontal thrust, is getting developed. Now provenance Himalayan range to north. Okay, now if we see the stratigraphy of Shivalik, so in the basement we have Muri or Dharamshala group, which we have seen just now, of middle Eocene to lower Miocene of age. Above that we have lower Shivalik, middle Shivalik, and upper Shivalik. Okay, the age of lower Shivalik is Miocene, the age of middle Shivalik is Mio to Pliocene, the age of upper Shivalik is Plio to Pleistocene. Now lower Shivalik is divided into Kamalyal formation and Chinji formation. Middle Shivalik has Nagri formation and Dok Pathan formation. And upper Shivalik has tetrode formation, pinjore formation, and in the top it has boulder conglomerates. Okay. Now if we discuss about the lithology of this, so Kamalyal and Chinji is most, it basically contain sandstone, claystone, red shells, and pseudo conglomerates. Nagri and Dok Pathan contain multi-story sands. This is important. It contains multi-story sands, and this Dok Pathan is more than 90% sandstone only, with minor claystone. Now in the upper Shivalik we have tetrode formation, pinjore formation, and boulder conglomerates, which is basically sandstone, siltstone, and some clays are present in that. Okay, and in the top we have boulder conglomerate. Now if we talk about the vertebrates present here, this is important question for exam. Okay, if we talk about the vertebrates present here, so if we talk about the lower Shivalik, which is Kamlial formation, here you have to remember this only, okay, because remembering all is very difficult. So telemastodon, okay, it is a type of elephant. And in Chinji we have Listodon, you can remember this name. Okay, in Nagri we have Mastodon and Hipparion. This is also elephant. In the top Dok Pathan we have Stegodon, which is a type of horse, and Mastodon. Sorry, this is also elephant. Then we have giraffoid, okay, and we have Mercicopotamus. Stegodon is also elephant. Okay, really sorry for that. Now after that in upper Shivalik, in tetrad formation we have Leptabos. Okay, in Penjor we have Eliphas and Stegodon, and in Boulder we have Equus. Okay, so you and Eliphas also, and we see buffaloes. So if you see here, the evolution of the horse is also visible here. Okay, because Equus and Eliphas are the modern day horse and elephants. So this is one of the most important slides. So in Kamliala formation you can remember Telemastodon, in Chinji formation you can remember Listodon, in Nagri formation you can remember Mastodon, in Dokpathan Stegodon, Mastodon, Giraffoid, and Mercicopotamus. In Tetrod you can remember Leptabos, in Pinjor Eliphas and Stegodon, in Boulder conglomerate we get Equus and Eliphas. So this is important. Okay, so this is the stratigraphy. And now if we talk about the environment, so climate at that time, what was the climatic condition at that time? So here we have already seen Kamlial and Chinji, and we have seen what are the lithology of that. Here Kamlial and Chinji basically contain sandstone, claystone, red shale, and pseudo conglomerate. About that, in Nagri and Dokpathan we have seen the multi-story sandstone is present, and the climate there was in Miocene in India was tropical, and heavy rainfall was there. Okay, now if we go above, in the Pinjore and Tetrod there was a arid environment, and it was little bit cooler. And if we go to the Plio-Pleistocene we get a glacial event, which is a Plio-Pleistocene glacial which occurred during this time. So this is the environment at that time. Okay, now this we have already discussed. So few names which I've highlighted here, you have to remember that name only for your exam. Okay, like in Kamalyal you can remember Telemastodon, in Chingi formation you can remember Listodon, in Nagri you remember Mastodon and Hipparion, in Dok Pathan you remember Stegodon, Mastodon. Okay, Giraffoid also you can remember because this is unique. In Tetrod you can remember Leptabos, in Pinjor you can remember Eliphas, in Boulder conglomerate you can remember Equus or and Eliphas. Okay, now we will move to Karewa formation, which is a part of Lesser Himalayas. Now in Karewa formation, if we talk about the Karewa formation, this is intramontane basin. Okay, this is intramontane basin, means basin which is formed in between the mountains. Okay, so basin which is formed in between the mountains or in valley. So I will write it here. So basin which is formed in between the mountains or in valley. This represent our intramontane basin, and it developed during Plio-Pleistocene time. Okay. Now, if we talk about the structure of the basin, so it is narrow, it is elongated, and it is thrust bounded basin. As you can see in this diagram, it is a thrust bounded basin, and it is 2 km of thickness. Okay, 2000 meter of thickness it is. Now, Karewa basin received sedimentation because of ponding of pre-existing river system. So basically, the lithology of this will include the deposition from the lacustrine and of fluvial origin. So the depositional environment is lacustrine and fluvial origin. Now if we talk about the tectonostratigraphy of this, okay, so here is our Punjab foreland and here is our greater Himalayas. So here it is north and here it is south. We get Murray thrust here. This is Murray thrust, this one. Then we have Panjal thrust. Okay, then we have Pir Panjal range. Then here Kashmir Valley is present. Here we have Zanskar thrust, this one, and here we have Great Himalayas. Here Punjab foreland is present and here Great Himalayan range is present. Okay. Now here I have written one important point. Ostracods fauna indicate the Pleistocene age of this formation. So from the ostracods we got to know that the age of this formation is Pleistocene. Okay. Now if we talk about the Karewa formation, it is divided into two parts, the lower Karewa and the upper Karewa. So if we talk about the Karewa formation, it is divided into two parts, lower Karewa and upper Karewa formation. So lower Karewa is also known as Hirpur formation. Lower Karewa is also known as Hirpur formation and upper Karewa is known as Nagum formation. So this is the diagram I have drawn here. So this is the lower Karewa, which is basically muddy lacustrine and muddy, and this consists of lignite. So this is important. GSI has founded the lignite, 560 million ton of lignite in this Karewa formation. So this is present in the lower Karewa formation. Okay. So the lignite which is founded by GSI is a part of the lower Karewa formation. Okay. Now above that conglomerate is there, then again mud is there, then we have an unconformity, then again we get conglomerates and sandstone, and above that we have aeolian deposits. So this is the diagram for it. Okay. Now if we discuss about, now this has completed about the Himalayas. Now we will move to Paleogene Neogene sequence of Assam. So Paleogene Neogene sequence of the rock are well developed in Assam and adjoining areas like Meghalaya's Naga Hills, Shillong Hills, Chittagong Hills, Surma Valley, etc. So if we talk about the stratigraphy of it, okay, so this is Paleogene sequence of Assam. So here we have Upper Cretaceous Mahadeva formation. Above that we have Paleocene. In that we have Langpar formation. Okay, then we have Jenta group, which is a part of Eocene. It has three formation in that: Theoria or Tura formation, Sylhet limestone, and Kopili formation. So this Tura formation is basically coarse sand, Sylhet formation is limestone, and Kopili formation is alternate shale and sandstone. Okay, then we have Barel group, which act as a source rock also for oil in this particular area. Okay, this act as a source rock also, source rock for oil in Assam Arkan Basin. So it include Lesong formation, Jenam formation, and Renji formation. So Lesong formation is sandstone with some shale, Jenam formation is carbonaceous shale, and Renji formation is sandstone with some shale. So this is our stratigraphy of Paleogene sequence of Assam. Then Neogene above it. Okay, so we have completed up to Barel group. So here Barel group is there. Above that we have Surma group. The age of this is middle to upper Miocene. Okay, it contain Buban formation. Okay, Boban formation, which is sandstone mudstone conglomerate. Then we have Bokabi formation, which is silty shale. Then above that we have Tipam group. This Tipam group contains Tipam sandstone and Girujan clay. Okay, so this Tipam sandstone is reservoir rock of this area, and this Girujan clay act as a cap rock for the petroleum system. So it has Surma group and Tipam group. So Surma group has Boban formation and Bukabi formation, and Tipam group has Tipam sandstone and Girujan clay. Okay, now if we talk about the Tipam group in detail, so Tipam group that overlies the Surma group, which you can see from here, it is above the Surma group, consists dominantly of massive sandstone with subordinate clay and shale. Therefore, as it contains a massive sandstone, it is a good reservoir rock of this area. The age is Myo to Pliocene. It is well developed along Tipam river, from where it got its name. Now Tipam group is divided into Tipam sandstone and Girujan clay. Now Tipam sandstone is massive ferruginous clay and it contains heavy minerals, and Girujan clay is variegated. Okay. Now Tipam sandstone are ferruginous and massive. Okay, they are rich in heavy minerals such as enstatite, kyanite, sillimanite, andesite, epidote, and hornblende. Few oil-bearing beds of and fossil woods are also present in this area. So this question came in GSI means 2023. Okay. So this question came in GSI means 2023 for 10 marks. So I have written like a 10 mark question only. So we have completed the Paleogene Neogene sequence of the Assam. Now we will move to the Cenozoic of Kutch. So if we talk about the evolution of the Kutch basin, so Kutch Graben is the earliest rift basin which opened up during the beginning of the rifting of Indian plate from the Gondwana land during late Triassic. So during the late Triassic, okay, the rifting has occurred when the Indian plate was getting rifted from the Gondwana. Okay, at that time the elongated rift basin has been created, which resulted in the formation of Kutch Graben. So after the graben has formed, the early sedimentation took place during the early rift phase of the evolution in the Indian western continental margin. The rifting was aborted in the late Cretaceous as evidenced by Jurassic Cretaceous regressive cycle. So this rifting was aborted in the late Cretaceous. So this is the diagram for this one, okay, which is not that much important for exam point of view. But if you can see here in the south and this is north, here in the south we have Katwar uplift, which is formed because of the rifting. Then we have Gulf of Kutch here. Then here we have mainland uplift. Then here we have Bani basin. Okay. Then here we have Pachama uplift, and here Run basin is there. Okay. Now the rifting took place in the stage by series of sub-parallel latitudinal faulting. So you can see the faultings are present here along the primordial tectonic trend starting from north. This has given rise to present step faulted structure tilted blocks. You can see here the step like features are present here. It is because of the faulting and rifting in this particular area, which resulted in the formation of different graben, which is later filled by the sedimentation. Okay, now in the late Triassic a narrow graben opened up in the north. Okay, here in the north a narrow graben has opened up first between the basin margin near Nagar Parker Fault and Island Belt Fault, which was filled up by the granite cobble conglomerate and arkose in the Rift Valley stage, and then between the Island Belt and the mainland, which was filled by continental Paralic Valley fill clastic dated. Now the first marine transgression started with the extension of the graben up to Kathiawar uplift by activation of North Kathiawar Fault during the rift-drift transition of the Indian plate movement. So this much detail is not required for the exam, but still you remember the rifting has took place, and that rifting was closed during the Cretaceous, and during the marine transgression, as we have seen during the Cretaceous time, there was a heavy marine transgression, and because of this heavy marine transgression the Mesozoic of Kutch was getting deposited. So we are basically discussing here about the Mesozoic time Okay, and after that, if we talk about the Cenozoic stratigraphy, okay, which is about the Mesozoic stratigraphy. So here during the Cretaceous time we see the Deccan traps here. About that, in the Paleocene we have Matanomad formation and Naredi formation. Okay, so in this is basically ferruginous clay stone and limestone and gypsous shale is present here. Okay, now if we further move here in the Eocene time we have Harudi formation, and here you can see the crossbeds. Okay, this represent the crossbeds here. So this represent the shallow marine type of depositional environment. Above that we have Fulra limestone. Okay, now above Fulra limestone during the Oligocene time we have Manyara fort. So in Manyara fort it contain coral limestone, okay, and clay. Above that we have Khari Nadi formation. Then we have Ch Chhasra formation, which is siltstone and claystone. So here this picture was taken by me. So you can see here in this Chhasra formation a lot of cross beds are there. Okay, so truncation of bed at the top, then coarsening of the sediment, and this ripple marks which you can see here, ripple cross beddings, is due to moderate change in the environment. Then frequent truncation of the bed in the top. So this you can see here the truncation of the bed. So this is the bed here. You can see this truncation of the bed here. Okay, this truncation of the bed you can see in the top, and then low energy environment at the top most part, therefore horizontal bedding is observed. Okay, so here we can see the horizontal bedding here. It is representing the low energy environment, and here there is a high energy environment. And what is important is this basically contains siltstone and claystone. Okay, now this you can read it by yourself. Okay, now the presence of microscale homochic cross stratification and frequent truncation feature, which we have seen in the diagram, attribute to indicate that sedimentation might have took place in the shore face area. Okay, so sedimentation took place in the shore face area, and you can see here there is no bioturbation is observed in this particular area, which result in the frequent deposition. So because of the frequent deposition, there is absence of burrows and other things are there in this particular area. So this is also written, the absence of burrows has indicated the sedimentation rate, which which may be high due to sediment influx during the delta progradation time. Now if we talk about the this formation in little bit detail, so if we talk about the Naredi formation, okay, main formation we are discussing. So the Naredi formation basically consists of shale, marl, limestone. It indicates the shallow marine environment with occasional lagoon condition. So this is talking about the shore face area, and then we have berm, and then we have lagoonal condition. Now the most of the fossils present here are foraminifera, and other marine fossils indicate warm, shallow, and marine setting during Paleocene. Now above that we have Harudi and Fulda limestone. So the lithology of the Harudi formation is characterized by shale, sandstone, and minor limestone, while the Fulda formation is predominantly limestone. Now fossils, if we talk about the fossils, the Harudi formation contains marine fossils such as foraminifera and mollusks, suggesting a shallow marine environment. The Fulda limestone also contain marine fossils, including continuation of the marine condition. Okay, so marine condition is continuing. Now further if we move, as this is a part of delta deposition, we are moving toward the terrestrial area. So when we go to Khari Nadi formation, it represents the fluvial and deltaic environment. Okay, so therefore the deposits which we get here are basically conglomerate sandstone and siltstone. Now fossils here are terrestrial fossils like mammalian remains you get. So these represent the terrestrial environment. Now above that we have Cutroll formation. Okay, the Cutroll formation compromises of the alluvial fan deposits. Okay, again terrestrial with conglomerates and sandstone indicating significant tectonic uplift during the erosion during this period. And here we see the aeolian deposits also. Okay, aeolian deposits or wind blown deposits also. Now, if we talk about the fossils here, we get terrestrial fossils here like myeolite formation consists of fossilized remains of the terrestrial organisms, suggesting arid to semi-arid climate. Okay, so this completes our lecture on the Cenozoic stratigraphy of India. In the next class, we will discuss the boundary problem in the Indian stratigraphy. So thank you very much for watching this video. Please subscribe to Bhuvigyan modules for this type of content.